Good afternoon. Good afternoon, everyone. Hope all is well. Hope everyone's doing all right. So, as always, we're going to give everybody a chance to get connected, give a few more seconds, and then we will get started. All right, so let's go ahead and get to it. Last class, we knocked out 4.1, so we're starting with 4.2 today. So we'll do 4.2 and 4.3. And we're looking at shapes of distributions, talking about how your data is being distributed. And so right here, these first diagrams, just emphasizing the fact that we use smooth curves to approximate the shapes of the distributions. So you can see that we have these bar graphs here. We talked about bar graphs, but the curves approximate the shape, And then also we have line, line graph, but the bar, not the bar, but the smooth curve will just approximate the shape that the line graph or the bar graph was trying to display. All right. Is everybody doing their sketch? Anybody sketching? All right. So next thing to talk about is the number of modes. Hold on, let me see something. Yes, number of modes. So uniform distribution is basically when, and I think I have it down here. Yeah. Uniform distribution is where it has no mode because all of the data values are pretty much at the same frequency. In other words, distributed at the same amount. That's why it's a straight line. Single peaked or unimodal don't have one mode. Excuse me. One mode. That means, remember, mode is that when you have that one mode, you have that one data value that shows up more than all the rest of them. Bimodal is when you have two modes. That's why we have two peaks here. Two different values that show up a lot. Let's see. Okay, not a problem. Somebody type me in the chat, guys. And then trimodal, having three modes, and you have three different values that show up, very frequently that you would have to acknowledge their presence. So you have these three peaks versus two peaks versus one peak, and no peak. Question? Can I scroll up? Anybody do anything that will stop me from doing so? Is everybody okay? All right. So here's just a light example of explaining or giving us applications or natural examples of when we would have a uniform distribution versus single peak, bimodal, trimodal, and so on. So it says, how many modes would you expect for each of the following distributions? Why? Make a rough sketch for each distribution with clearly labeled axes. So we're looking at the heights of 1,000 randomly selected adult women. B, hours spent watching football on TV in January for 1,000 randomly selected adult Americans. Weekly sales throughout the year at a retail clothing store for children. And the numbers of people with particular last digits 0 through 9 in the Social Security numbers. All right, scrolling up some. Here are the sketches, and I have a little bit of an explanation right under it, but just giving you guys a chance to write. All right, so let's look at A. So A is a single peak. We're talking about heights of 1,000 when randomly selected adult women. So A is a a single peak, basically because most women have a height that is around the average. Whatever the average is, most, that's, you got average height of women. They're not multiple averages as far as the height of women is concerned. There's the average height of women, and then, you dissipate from there. So that's why A is a single peak. B, we have the hours spent watching football on TV in January for 1,000 randomly selected adult Americans. So notice the way they labeled the peaks. You have the mean time for casual fans, then the mean time for big fans. And then you have this little downtime in the middle. Well, that's where most people fit. You got the real big time fans, the extremists. Then you have the casual fans. And then you have a lot of people that are in between that. That's why it doesn't go all the way down. But you have these two major peaks or two major categories of casual fans and then big time fans. All right. Then for C, weekly sales throughout the year for the retail clothing store. So you have three major purchasing seasons: spring sales, back to school, and then holidays. And so that's why you have those three peaks. And then for Social Security, you see that as unimodal. I mean, not unimodal, it's uniform, not unimodal. Unimodal is the one peak. That's uniform distribution. There's no peaks. So Social Security numbers are randomly chosen, so the generated numbers should be about the same. All right. Any problems before I scroll up? Am I still copying?
What would change D to be a different type of graph?
It would, it would have to be a different scenario altogether. Um, Basically, if your social security numbers were chosen, I guess, in a different way, since it's done randomly, it's generally created, so there's no real rationale. Maybe if there was some system in which uh, fives were used more in the beginning, wherein, somewhere, basically there will be this mound wherein there's fives that are majority here in this category or something like that in comparison to all the other numbers or something like that. But because social security numbers are randomly chosen, there's nothing that's gonna, make a peak. So
Okay.
yeah, hope that makes sense. Um, Everybody done with the red? Okay. Okay, next thing they're talking about is symmetry or skewedness. So if something is symmetric, that means that you can draw a line in the middle and what's going on the left is reflected exactly to what's going on in the right and vice versa. So you notice what this statement says down here, these distributions are all symmetric because their left halves are mirror images of the right halves. So it's not about having one peak, two peak, three peaks. It's about having that mirror image on the left and right. All right. Everybody good? So that's symmetry. Now we're looking at being skewed. Let me erase some stuff. Everybody done with the sketches? All right. So let's look at the first one, being skewed left. That means the mean. Well, we'll talk about two different ways you can look at it. The first one they have down here, the mean and median are less than the mode. So what I got right here is just the generic number line. You know, if you have, you have zero in the middle, everything to the right of zero is one, everything, I mean, is positive, everything to the left of zero is negative. Always remember that if something is farthest to the right, that means it's greater than whatever's to the left. So if I look at the number two, everything to the right of two is greater than it. Everything to the left of two is less than it. If I look at the negative one, everything to the left of negative one is less than it. Everything to the right of negative one is greater than it. So the reason why I go there is because that's how this is described. We just want to make sure we have the right thought process when we're looking at it. It says to be skewed left means that the mean and median are less than the mode. So the mode is right here, and see the mean and median are to the left. So it means that they're less than the mode. I just want to make sure we clear what they're trying to portray visually. Also, if it's skewed left, that means the tail, excuse me, the tail of your data is going to be to the left. So majority or the bulk of your data would be here to the right, but then the tail of your data would be to the left. Outliers at low values. Skewed right. If it's skewed right, then the mean and median are greater than the mode. So notice the mode is right here. Mean and median are to the right. Remember, if it's to the right, it's greater than it. If it's to the left, it's less than it. And then also, if it's skewed right, the tail of your data is to the right. So the bulk of your data is over here to the left. Then you have outliers at high values to the right. And then we just finished talking about being symmetric, but if it is symmetric, then the mean, mode, and median are going to be the same. And this is also called a normal distribution. Normal distribution. And we will talk more about that as we progress forward. But the normal distribution is this bell-shaped curve right here. Before bell-shaped curve. Any questions? Any questions before I scroll up? I still copying in the good. All right, next thing is a variation. Variation describes how widely data are spread out from the center of the data set. So here are a few sketches of data values, not data values, but of distributions increasing in variation. So this one is low variation, moderate variation, you see it get more spread, and then high variation is right here. Yep, let's scroll up. So that's it for 14. Any questions before we go to 4? All right, now scroll up, scroll up, scroll up. All right, so 4.3, measures of variation. So the first thing that we're gonna look at is the range. So your range is your highest value, which is your max, minus the lowest value, which is your minimum. So if I had my, my famous data set of 1, 2, 3, 4, 5, I would do 5 minus 1, and that would be 4. My range of data would be 4. Let's see, I want to. I'm just repositioning these because I did them in different order. I guess I'm really just being lazy. I could just rewrite this stuff. All right, so next things, quartiles, the 5-number summary, and box plot. All right. So your quartiles, they divide the data set into fourths. So I have a little mini diagram of what that means right here. So you have your minimum and maximum on the outsides. You have Q1, Q2, Q3, and they should split your data into fourths, 25%. All right, so finding our quartiles. First, we want to list the data values from least to greatest. Don't forget that step. A lot of times people forget that step. Then we're going to find Q2. It is the median of the whole data set. In other words, you can take Q2, split the data in half. And we talked about medians last class. That's just the middle values. And then to find Q1, that's the next step. It's the median of the first half of data. In other words, you can take that first half of data, split that in half, and then Q3 would be the median of the second half of data. And you take that second half of data, split that in half. So you just find the three middle values. Q2 is the middle value of the whole data set. Q1 is the middle value of the first half of data. Q3 is the middle value of the second half of data. All right, can I scroll up? So we're gonna find quartiles in a second with some numbers, but at least gonna go ahead and give you these for what it means to be to have a 5-number summary. So right down with that purple. 5-number summary is just the smallest value, Q1, Q2, Q3, and then your maximum value. All right, scrolling up. Also, the box plot. Anybody holding on to the blue? Box plot is a graphical tool used to compare groups of data. It consists of a box with lines that extend to the minimum and maximum values. These lines are called whiskers. And I meant to write this last class, but I didn't do it. Questions on what we did there, or what I've written so far. So you notice you have your 3 lines, vertical lines that are representative of Q1, Q2, and Q3's positioning. Then the whiskers extends out to your maximum minimum value. All right. Pulling up. All right, so I already wrote on this a little bit, but let me erase this stuff so we have a clear visual of what the data set is. So this is my data set: 4.1, 5.2, 5.6, 6.2, 6.7, 7.2, 7.7, 7.7, 8.5, 9.3, 11.0. So I wrote my data values already in from least to greatest. That's why you see that number one right there. That's the first step, write the data values from least to greatest. But also what I do is I will count how many data values that I have. So we have 11 data values. And you don't have to do this, but I write my data values broken up into halves. So I know I had 11 data values. That means I was going to have five here, and then one in the middle. That just helps me to be able to analyze my data properly or easier. But you don't have to do it, but you do have to write them from least to greatest. So it's up to you how you want to write your data values. But if you write them and you go ahead and break them up according to how many should be in the first half versus how many should be in the second half and all that, it'll be easier to find your middle values. All right. So with that being said, I know I need my Q2 first. And that is my 7.2. That's my legit middle number. I had 11 data values. Since it's odd, I know I'm going to have a middle number, and that is 7.2. So don't forget, if it's even though you're trying to find your median, you do have to take the two data values in the middle, add them together, and divide by 2. All right. Hold on, let me see my Q1. All right. So here, now the second step is to find Q1, or second step after you list your data values from least to greatest, but it's actually our third step to find Q1. I have 5 data values here. Right, a little better. So I have 5 data values in this first half of data. So that means I have a middle number. That's 5.6. So once again, if I had an even number of data values, let's say if I had a 7.0 over here, then I have to take my 2 middle numbers, add them together and divide by 2, and that would be my median. So like I said, it's the same thing that we talked about last class as far as finding your median is concerned. And then same thing for that second half of data. I have 5 data values. So my middle number is 8.5. All right. Any problems with anything so far? Closing up. There's my 5 number summary. This makes a difference. It's okay. Just playing around with colors while you guys are copying stuff. So 5 number summary, minimum Q1, Q2, Q3, then our maximum. Then our box plot made up of those numbers as well. And that's it. That's it. Questions on anything? All right, so everybody good? First scroll up. All right, next thing in this section are your percentiles. So if you want to calculate the percentile of a data value, it's the number of values less than the value that you're talking about. And it's going to be divided by the total number of values in the data set. You multiply that times 100. So your percentile represents the percentage of values less than or equal to the value in question. All right. So our example under percentiles, what is the percentile for the data value of 104.54 nanograms per milliliters for smokers? So there's a chart on page 138 if you want to check that out. But I'll give you the numbers. But that's where I'm getting the numbers from. You know, you read the chart. Get the numbers from the chart. Anybody holding on to this green statement? So what is the percentile for the data values of for the data value of 104.54 nanograms per milligrams? Milliliters, excuse me, I said milligrams, milliliters, nanograms per milliliters for smokers, and it's milliliters of blood. So first you need to count the values that are less than 104.54. So when you go to the chart, count the values that are less than 104.54. There will be 34 values that are less than that number. Then count the total number of the total number of values, period. So there are 50 values altogether. Once you have those two pieces, you can use the formula. It's 34 over 50 times 100. And we have the right statement about it. This number marks this number of 104.54 marks the 68th percentile. Questions? Any questions? All right. Standard deviation is a measure of how widely data values are spread around the mean of the data set. So for this class, I'm not going to hold you responsible for knowing how to use the formula, but you do need to have something that's reliable in order to help you calculate the standard deviation, whether it's a WAP, I said WAP, an app website, or calculator. I'm not asking you to purchase anything new. Free stuff. It's all around the place. So you see, I suggested easycalculation.com. I'll show you how that one works in a second. But you just need something that's reliable that will help you to calculate the standard deviation. The formula can be a little involved depending on how many data values you have, but it's one of those formulas that you mess around and mistype one data value or you miscalculate one time in the process, it messes up the rest of the process and your answer is going to be incorrect. So, once it goes over 20 data values, something like that, it can be a little problematic and tedious. But once again, you guys aren't held accountable for the formula or using the formula, but actually knowing how to calculate, having something that will calculate the standard deviation for you. And then we're going to get into the application of the standard deviation later. So if I just use my data set of 1, 2, 3, 4, 5, and they ask us to find the standard deviation. So if I do standard deviation, easy calculation, that's if you want to use easycalculation.com. All you do is type in what you're looking for, do easy calculation, and it should be the first one. And then from here, follow instructions, says enter all, it has a bunch of apps. Enter all numbers separated by commas. So that's 1, 2, 3, 4, 5. And hit calculate. And we see that's our answer here. So notice it has standard deviation and variance. They didn't ask in this book, they didn't ask about the variance. So until it pop up, I'm not worried about it. Right now, all you're looking for is the standard deviation. Also notice it has population standard deviation, population variance. I'm pretty sure, I thought that was one of your definitions, but I don't really think about the old book. But when you talk about this, the population versus the sample is exactly how it sounds. If you take the student body of TCC, that is the population. That's the larger body. And a sample is a select group or select number of people or select number of data out of that population. So this class would be a sample of TCC student body, which is the whole population. So notice we only have 5 numbers here. So with only 5 numbers, it's hard to believe that that would be a population. So that would be assumed to be a sample. But this one is not labeled sample because they labeled this one population. So since this is the population, then they assume you know that this is a sample. So that's the one we pull 1.58. Questions on any of that? Once again, you don't have to use easycalculation.com, but you just have to make sure you have something that is reliable that can calculate standard deviation for you. All right. Questions on anything at this moment? There may be one more thing out of this section, but I want to check your MATLAB work first to see if it's in there. I didn't want to waste time going over something that's not, that you guys aren't held accountable for. So I'll check it out. If so, then we'll knock it out next class along with section 4.4. 4.4 is just a section talking about, it's more wording, just like the last section 3.4, when he was talking about just pitfalls and stuff when it comes to graphs, things to watch out for when it comes to graph. Same type of deal with 4.4. So next class, we'll do that. And also we'll set a date for our proctor test. Remember we talked about that. And we'll go into detail about how we're going to handle that. I'm thinking what it will probably be, this is Wednesday. It probably won't be until the 26th. That's what if I'm just looking at it, right now. But like I said, we'll talk about that on next class. So before I close out, any questions? Any questions at all? Everybody good, everybody straight.
So the test that's going to be proctored, that's going to be on Monday.
When you say Monday, you talking about the 26th?
Yeah, the next Monday coming up.
Yeah. Well, that would be the earliest that it would be. Yep.
Okay.
Mm. Nope, just 4.4. I'm not gonna go any further, and I don't know if everybody can see that in the chat. Yeah, it wasn't very much. One of your classmates asked, were we gonna do anything else other than 4.4? No, since we're closing out chapter 4, that means that we're getting to test 2, because test 2 is chapter 3 and 4. So I didn't want to jump into 5, and we didn't even review chapter 4 and 3, or didn't even set it up because we got a test coming. So I don't want to add stuff in. Yeah, so we're just going to do 4.4. Yep. Anything else? Anybody else? Yeah, no problem. Okay. If you guys are good, I'm good. Take this time out, get caught up with Math Lab. See if you have any questions, bring in the class, next class. Also, if things go according to class plan, we'll do close out chapter 4 on Monday. Probably have some time there if you want to ask questions because it's only one section. And then the next Wednesday, we'll have a review day that day is set aside just for questions, period. And then come back and have that test. All right. So you guys have a good one. Be safe. Have a great weekend. And I will see you on Monday.